Hello again. Alright, well, we're working on exercise 8C today. So, exercise C is just mainly something about planar graphs. Now, a planar graph, as you can see by the definition on the screen, is a graph that can be drawn on a plane, so just on your page, so that no edges intersect except at the vertices. So, this one here is a planar graph. You see, none of the edges cross over. However, in example 4, this is not a planar graph because the edges A to C and B to D cross over. So this edge and that edge cross over. However, most of the time what we would like you to do for this exercise is just to redraw the diagram so that there is no intersection part to it. So I'll try the first one. Okay. So there's going to be multiple ways of doing this question and there's going to be multiple answers. So if you don't get something exactly the same as mine, that's okay. You just need to make sure that none of the edges cross over. So I'm going to keep that edge, I'm going to keep that edge, and I'm going to keep that edge. And I'm going to make the edge A to C go around like that. See, now none of the edges are crossing over. And that's essentially what a planar graph is. Now, if I wanted to draw something different, I could have done something like this. Let's see. I need A connect to C, so I can do that, and then B connects to D. So I can do that if you like as well. So that's what we mean by there's going to be different answers. All right, let's scroll down a little bit. Let's look at the next example. All right, the next section we're looking at is something called the faces of a graph. The faces of the graph is just the regions or the areas that are enclosed, I guess, by the edges. The only thing you need to remember is that the outside counts as another face. So as you can see by this example, there's two faces. There's the inside one and the outside one. So a face is a region of space. The space may be enclosed within the connected edges of a graph or the space surrounding the graph. So that's what a face is. Next, we've got Euler's formula. Now, Euler's formula is just something you keep in your exercise book, and the number of vertices plus the number of faces should equal to the number of edges plus 2. And it always works for connected planar graphs. So most of the time on a SAC, we'll just ask you to verify Euler's rule. So as you can see here, we'll try example 5a. It says write down the number of vertices, edges, and faces. Now, edges is easy. No, vertices are easy. Just look at the dots. So A, B, C, D. That's 4 vertices. So for A, you've got 4 vertices. Number of edges. So I normally mark them. So 1, 2, 3, 4, 5, 6. 6 edges. 6 edges. And in terms of faces, there's 1, there's 2, there's 3, and 4. Because the outside counts as 1 as well. So that's 4 faces there. Now, in terms of verifying Euler's formula, this is the steps you must all take. You start by writing the formula, and then you substitute. So there's 4 vertices, 4 faces, 6 edges, and 4 plus 4 is 8 is equal to 6 plus 2, which is 8. And then you just make the sentence, therefore Euler's formula verified. Okay, so please make sure anytime we ask you on a SAC this year or next year to verify Euler's formula, that's pretty much what you've got to do. Okay. All right, let's see any more examples. We do. We have a few here. Now, this one's a little bit trickier. Vertices first. Let's go with that. So for A, vertices, what do we have? 1, 2, 3, 4, 5. 5 vertices. Edges. Now, edges. 1, 2, 3, 4, 5, 6, 7. So just double checking, E all the way to B counts as 1, so there should be 7 edges here. Now, you see how there's a line that crosses through others? You can't actually see the faces when there's lines crossing through. So what you need to do, and also this graph here isn't exactly planar. Euler's formula only works for planar graphs, so you have to make it planar. And the line that we're going to change is the line that goes from E to B. So please keep that in mind. We will do it to trick you. This looks like there's 1, 2, 3, 4, 5, 6 faces, but it doesn't. If A is here, B was here, I'm missing one. I'm going to make it up. C is here, D is here, E is here. Now I need a line from E to B, so I'm just going to go around like that. See how this graph is now planar? So that's 1, 2, 3, 4, 5. So there's 5 faces in this one here. Alright, now part B, verify Euler's formula. So V plus F is equal to edges plus 2. I think that's right. Yes, V plus F equals the number of edges plus 2. Now let me just double check my edges. 1, 2, 3, 4, 5, 6, 7, 8. As you can see, I cannot count. There should have been 8 edges there. Alright, so number of vertices, 5 plus faces is equal to 8 plus the 2. 10 equals to 10, therefore Euler's formula. Verify. And that's it. There's a couple more formulas here. Sometimes we won't give you the picture, we'll just ask you to solve stuff for something. So here for planar connected graph, so any planar connected graph, Euler's formula works. So vertices plus faces is equal to edge plus 2. The question is find the number of edges, given it has 4 vertices and 6 faces, is equal to e plus 2. So do the steps, the substitution. And once you've done that, you can use your CAS to solve if you wish. So solve 10 is equal to e plus 2, comma e, and you've got 8 edges there. Now the same thing for the second side. We've got 4 vertices. We're looking for the faces, 5 edges plus 2. Use the solve function, or you can do it manually, but there's 3 faces in that question there. And that's it for that exercise. Thank you.